So before we go into the panel, I want to just tell you a little bit about JSPG and what we do. So JSPG is an internationally recognized and open access research publication, which is peer reviewed, but we're also a nonprofit. And in addition to publishing work by early career scholars, we also promote the work through a number of channels. Our main goal is to really empower and think about how we might elevate early career researchers in science policy through their research as well as through different events. We're managed by and for students as well as policy fellows and early career scholars from all academic and professional backgrounds, and I'll show you later that we're covering a pretty broad range of areas. And in addition to publications, we really want to be also a forum for debate and discourse in science and technology policy, again, engaging early career researchers in different areas of policy. Our mission is to help students and early career scholars of all academic backgrounds bolster their research and writing credentials in science and technology policy. And we really encourage them to engage and contribute to policymaking at all levels of government, local, national, international, etc. And as I mentioned, we also promote published work through social media, our global mailing list, as well as outreach in different channels through Twitter, LinkedIn, etc. And we're pretty active on Twitter as well, so you're welcome to follow us there. And in terms of what we publish, so as you can see here, we publish in a wide variety of formats, op-eds, technology assessments, white papers, etc. So you can check out our website to learn more. And wanted to also share that we publish, as I said, on a variety of topics. You can see here, it's pretty broad. Just to give a few examples: government, university, industry interfaces, scientific research policy, applications of technology in developing countries, internet policy, STEM education and workforce, science communication, etc. So we really try to be pretty broad in terms of science and technology policy and cover a lot of different areas. And as I said, we're unique in that we focus specifically on early career researchers. And in addition to the publications that we promote, we do this through a number of channels. So one of the publications that I wanted to show you here is with the United Nations Major Group for Children and Youth, where several of our authors have published, including George, who's here today. And this is a great partnership with part of the UN to think about how we might use technology in a equitable way and for public good. So we did publish this and then had a webinar with the group, which was a really exciting conversation around technology. We also do other webinars related to more science policy careers. So you can see this one in the middle with the AAAS Science and Technology Policy Fellowships, which we did in September. And it was a really nice discussion of individuals who are currently fellows or past fellows who have leveraged their skills as well as their work with the journal to advance their own policy careers. And then more recently, we started a podcast called SciPol Soundbites, where we really are interviewing authors, again, focusing on early career authors who have published in the journal, and we want to hear from them about their publication and broader implications. This is just one of the episodes here, and we'll be continuing with this. We just finished the first season based on our issue with UNMGCY, so we encourage you to follow this as well and subscribe to our channels. In addition, we've also started doing more trainings this year with the National Science Policy Network. So they organized a science policy memo writing workshop where we discussed sort of the fundamentals of writing, had a really good practice session. And we are also partnered with the University of California, Irvine on the certificate program for science policy and advocacy for STEM scientists, which we started in June of this year. And you can see here a number of partners. The course is meant to train early career researchers in policy skills in terms of writing, elevator pitches, et cetera, as well as give them a little bit of real world experience to pitch to staffers and network with policy professionals. So it's been an exciting year. And part of my role at JSPG is to extend this into several events, as well as the podcast and the session that we're doing here today, to again elevate our authors and our issues and discuss different areas of policy as we are discussing space policy today. So I encourage you to check out the journal, and I'm happy to discuss more following this session if you'd like to know more about JSPG. So with that, I would like to introduce Sara Crandall, who is an astronomy and astrophysics PhD student at UC Santa Cruz. And she's also an associate editor for JSPG. In 2019, she was a Christine Mirzayan Science and Technology Policy Fellow at the National Academies of Sciences, Engineering, and Medicine as part of the Space Studies Board. And you can follow Sara on Twitter at SaraRClan. And with that, I'll turn it over to you to introduce our panelists.
Great, thank you so much. I am very excited to introduce our three panelists today. We have a wide range of expertise here, and I'm excited to hear from them. Feel free to put any questions in the Q&A. We will answer them after each panelist discusses their topics. So we're going to start with George Profitiliotis. He is an electrical and computer engineer and PhD candidate at the National Technical University of Athens, Greece. In his position there, he explores national planetary protection policies for private activities between Earth and Mars. George is also a Foresight expert at the UNESCO Chair on Futures Research in Greece and a JSPG published author. All right, on to you, George.
Thank you so much for the invitation. Let me try to share the screen now. Let's see. Let me see. All right. I think that would work, right? Yeah, all right. So thank you everyone for joining us in this session. Let me hide the thumbnail view. All right. I will try to give you a broad overview today of the major bioethical issues regarding space exploration in light of emerging private space activities, especially with a focus of planetary protection, which is the subject of my PhD research. So let's start because we don't have much time and there's a lot of things to cover. So first of all, as you may already know, there are some space initiatives that are currently on the rise, especially private ones. And this emergence of private space activities has already begun to push the boundaries of the space industry, thanks to some innovations that will soon be able to facilitate the development of some markets that were previously neglected, such as research science, exploration, and space resources utilization and human access to space. And these involvement of private actors in space exploration has already been acknowledged in the past in the Global Exploration Roadmap of 2018, which is a consensus of report of 14 space agencies. And as you can see here in the Global Exploration Roadmap, there is a significant involvement of private space actors, especially in between Earth and lunar exploration. But the fact is that private space activities are evolving in a pace that was not seen in the past, and NASA has been facilitating this development with the recent commercial crew programs, the Commercial Lunar Payload Services Program, and the Human Landing System Program that are currently paving the way for commercial space missions towards a range of destinations, including the International Space Station, but also the Moon. And as you may have heard in the news, commercial sample return from the Moon is already an open issue right now. It has been proposed, but also lunar tourism is another real business objective of some specific private companies that are being involved in the expansion of private activities to the Moon. And now, of course, future private space activities may consider Mars as a candidate goal into the future. And the fact is that NASA's Mars Cube-1 CubeSats have already demonstrated the use and proven the concept of using miniaturized spacecraft for the unmanned exploration of Mars, which may open up the path for potential future private unmanned exploration to Mars. For example, BERSET-2, which is a mission and a spacecraft that is currently being developed, may already be considering Mars as a potential target. And in addition to that, commercial sample return from Mars and crewed space stations on the surface of Mars or around it seem to be the desirable long-term objectives of some specific private companies that you may already have in mind, which are already currently involved in space programs that are phased towards the International Space Station and the Moon. So Mars might be a longer objective, but it could potentially perceivably be the next step. The thing is that human missions to Mars are not without hazards, and there are 6 main important categories of hazards for humans with respect to space exploration, and especially Mars. Microgravity and reduced gravity is one of them. Microgravity during the travel towards Mars, and reduced gravity on the Martian surface. High radiation levels, of course, since missions to Mars will be out of the Van Allen belts and the Earth's magnetosphere, and isolation and confinement of the astronauts in the tight quarters of a spacecraft on its way to Mars, and also on a habitat on its surface or around it, or in orbit around Mars. The absence of basic terrestrial ecosystem services is also a hazard, since all the recycling of liquid, solid, and gaseous wastes should happen in a non-natural way, using either biological or physical chemical technologies. Of course, Mars on its surface has a very abrasive dust regolith, which also poses specific hazard to human health. And the last but not least is the potential biohazard that could be posed to astronauts by putative Martian microorganisms. And this is one of the things that we will focus in this presentation. At the same time, it's not only Mars that poses hazards to humans, but also humans themselves can put Mars at risk. There is the article number 9 of the Outer Space Treaty has already stated that state parties to the treaty shall pursue studies of outer space, including the Moon and other celestial bodies, and conduct exploration of them so as to avoid their harmful contamination. When you have human crews exploring Mars, specifically, as you can see in these examples that I have on this slide, human-related contamination is an issue that has already been predicted, let's say, by article number 9 as harmful contamination, because of the pressurized spacesuits that are being used by astronauts, and the pressurized habitats that will be used to make them able to survive in the Martian environment. Human-associated microorganisms might escape due to leakage to the environment of Mars, and thus pose hazards to what the article number 9 of the Outer Space Treaty is referring to. And this is the foundation of planetary protection policies based on international law, which we will explore afterwards. Now, let's start with one of the 3 major categories of bioethical issues with respect to space exploration. The first one refers to terrestrial microorganisms, terrestrial plants, and terrestrial animals. And as I said before, the fact that terrestrial ecological services are not available on Mars or in transit towards Mars, creates a need for the creation of a life support system, which is the system that provides water, oxygen, and food to astronauts by recycling the wastes. And terrestrial microorganisms and plants are already being studied by space agencies in order to be integrated into future artificial ecological systems. At the same time, as I said before, humans are carrying with them microorganisms associated with their microbiome that they will naturally follow astronauts everywhere. And at the same time, there is also research that's being done with respect to biotechnology and synthetic biology for the creation de novo of living organisms, or for the modification of existing organisms, so as to create functional tools, let's say, of organisms that will fit in an artificial ecological system in the future. With respect to animals, the thing is a little better, let's say. Since the beginning of the space program, animals have been sent into space for experimentation with the goal of collecting biomedical data, as well as testing experimental systems that were being developed for subsequent use by human crews, of course. But from that point onwards, the goal has now been reformulated into the investigation of effects of the space environment on various biological processes. And animal welfare is now considered to be a critical factor. For example, you can read the NASA Principles for the Ethical Care and Use of Animals of 1996. So this is a summary of the bioethical issues with respect to terrestrial microorganisms, plants, and animals. First of all, should we treat animals in space in a strictly instrumental manner and as research subjects, or as friends and companions to our astronauts and as our envoys? And what should be our stance regarding the intentional dispersal of terrestrial life to other celestial bodies, as I said, for example, with the example of contamination? And if we support intentional dispersal of terrestrial life, which species should be selected and who will select them? And what should be the destination and the future of this dissemination of life beyond Earth? Just keep them in mind for later Q&A session. Now, the second pillar of the bioethical issues for space exploration is, of course, humans. And mission crews are at the same time pioneering explorers, but also experimental subjects. And they put their safety at risk to provide the benefit to the society of novel knowledge because of the status that their profession gives to them, the ability to use their profession as a tool to provide benefit to the society. But at the same time, after the launch, it is not possible for them to quit the mission in case they want to. And they cannot revoke their consent for the case of potential long-term consequences. Before the Space Atlas program, the biomedical health-related data of the astronauts were being published, accompanied by personal identifiers of the astronauts. But since the creation of the International Space Station Code of Conduct, especially Article number 6, now the protection of human research subjects demands written authorization by the Human Research Multilateral Review Board and informed consent by the astronauts, so they are being protected in a very strong manner, let's say. At the same time, it's not only astronauts themselves in the strict sense that are gaining access to space due to private activities, but also spaceflight participants, for example, civilians, tourists, engineers, technicians, and support personnel that are not actually considered astronauts in the strict sense right now, because they're not governmental employees in the sense of the astronaut as this profession is being considered. So it may be possible that they may be treated differently by the various space treaties. And there are also some gaps in pre-flight, in-flight, and post-flight activities, especially with respect to the issue of underage spaceflight participants, children. At the same time, long-term missions to Mars are expected to cause health and social problems to the astronauts, since the constant biomedical monitoring and the dependence of life support systems and the control on the end of life and beginning of life matters, and also the need for physiological selection and enhancement are things that are already being discussed, and they may need our attention very soon into the future. And with respect to planetary protection, which is what I started the presentation with, in case of a biohazardous agent that could be brought to Earth through the bodies of the astronauts, a quarantine may be needed, which also raises specific bioethical issues. So the summary is this. What should be our stance regarding the involvement of humans in long-term and high-risk missions, especially in one-way missions? and how adequate is the information regarding risks and their assessment for the informed consent of interested civilians, spaceflight participants. And does the extreme environment context change our stance regarding traditional topics of biomedical ethics? For example, enhancement or beginning of life or end of life matters. And also, should we allow astronauts that seem to have been exposed to another planetary environment and present with symptoms of illness to return back to Earth, the quarantine issue that I mentioned? If we allow the return, under what circumstances should that happen? Keep them in mind. And now this is the last pillar, which is connected to planetary protection more closely. The thing is that current planetary protection policy states that Mars should be protected from its contamination with terrestrial microorganisms and should be preserved in a pristine state in order to safeguard the search for extraterrestrial life against false results, which means that planetary protection policy protects the search for life. In an event of a successful discovery of extraterrestrial life, the current planetary protection policy is unable to offer guidance regarding our stance towards extraterrestrial life and its management in general. Of course, this gap has already been identified, and there is some work that is already being done, as you can see, with several workshops and working groups that are being deployed around the world to try to tackle this issue. And the terraforming of Mars or its para-terraforming, like terraforming part of Mars, in order to make it more welcoming to terrestrial life, which has been a vision of some private companies, may in fact cause a direct conflict with the potential presence of extraterrestrial life on Mars and also with its protection. But the same case is with the extensive use of habitation systems, even without terraforming. And this means that private human activities may be hazardous to Mars due to a need to utilize water for the life support systems, water resources that may harbor extraterrestrial life, or to biotechnologically utilize the extraterrestrial life itself. And another thing that has been proposed in literature is on the other side of the terraforming coin, the eco-pieces of Mars, which is the modification of Mars for the benefit of its indigenous life in a way that restores the planet's ancient ecosystems. And this is a summary. Does extraterrestrial life have intrinsic value? And what is its moral status? Should it be protected? How does our stance regarding these last three questions differ in the case of extraterrestrial life from a second genesis, compared to our stance in the case of extraterrestrial life that shares an evolutionary origin with terrestrial life? And should we allow the mixing of terrestrial life and extraterrestrial life on other celestial bodies? What should be our stance regarding the intentional dispersal of extraterrestrial life to other celestial bodies? These last questions are strongly connected to planetary protection, and planetary protection is actually a set of measures of policies and guidelines and practices, and also methods and technologies with the goal of preventing the contamination of celestial bodies with terrestrial biological material, and of preventing the contamination of the Earth's biosphere, of course, with potential extraterrestrial biological material. And private space activities could potentially give rise to this kind of planetary protection issues. And such examples, unfortunately, have already occurred recently, as you can see in these pictures. And as you can see also in these news clips that I have included in this slide, private space activities that are posing planetary protection issues are because of a specific planetary protection policy gap that exists, which is because of what the article number 6 of the Outer Space Treaty states, which says that state parties to the treaty shall bear international responsibility for national activities in outer space, including the moon and other celestial bodies, whether such activities are carried on by governmental agencies or by non-governmental entities, and for assuring that national activities that are carried out are in conformity with the provisions set forth in the present treaty, which means that the states are the sole responsible as far as the Outer Space Treaty is considered, and states are the ones that should try to regulate private activities. And this is the conclusion. It seems that the bioethical issues that are related to the various fields of space exploration can be grouped into two categories. The first one is general bioethical issues that are also present in a wide range of terrestrial cases as well, such as risk acceptance or end-of-life matters. And also in a spatial bioethical category, let's say, with issues that are intrinsic to the context of the space environment, such as the protection of extraterrestrial life, which is also connected with planetary protection. So that was all. I tried to give you a broad overview as fast as possible. I hope I didn't take much of the time. And thank you very much again for listening to the presentation.
Thank you, George, for giving us like a wide range of questions to be asked about planetary protection. It's such a big project to undertake. So thank you for that. Okay, so next we have Therese Jones, who is a Senior Director of Policy at Satellite Industry Association. At SIA, she supports government services, regulatory, legislative, defense, export control, and trade issues of critical importance to the association's members. Therese is currently a PhD candidate in policy analysis at the Pardee Rand Graduate School. So I'll give it on over to Therese. Thank you.
Thanks so much for that introduction, Sarah. And a little bit more about SIA. We represent over 50 different satellite companies, related companies across, they all have a US presence, but many of them are international. So everyone from satellite operators to manufacturers to launch providers to those who build ground equipment. So pretty wide variety of stakeholders there. I wanted to sort of go at a high level and talk about space governance before going into some of the more ethical issues right now, since I know not everyone has a great space governance background. George talked about this a little bit in his presentation, but wanted to start with the Committee on the Peaceful Uses of Outer Space and a little bit about them. So they have been around really since almost just after Sputnik launch. There was recognition that there was, a need to regulate what was going into space on an international level. And so starting in the 60s, we had in 1967, I want to say it was, the Outer Space Treaty was ratified. And then there were sort of 3 subsequent treaties throughout the late 60s, early 70s that were ratified by the Committee on the Peaceful Uses of Outer Space. And they talk about things like liability in the case of a collision, responsibility to rescue astronauts in space, not being able to, claim property in space, things like that. But the problem with this committee is that it requires consensus. And now they're at, I believe, 95 members of different nation states. And so as you can imagine, it's rather difficult to get 95 countries to agree on anything. So a lot of times, people who are less familiar with this process are like, oh, let's solve this new space problem by getting COPUOS to come up with a new legally binding treaty. And that's very unlikely to happen at this point, just because of the variety of stakeholders that are involved. What they do, though, is they do meet annually in one big group, and then they have a technical scientific subcommittee and a legal subcommittee that also meet once a year. They're good at coming up with things like, non-binding guidelines. So one of their big efforts recently was guidelines on the long-term sustainability of outer space. That were agreed upon by the members of COPUOS, but it's sort of left up to the countries to implement them voluntarily in their home countries. And then there have been a lot of bilateral or multilateral negotiations amongst the members of COPUOS, which I think Chris will talk about a little bit in his presentation. So that's sort of where we are on space cooperation internationally. COPUOS is run on the administrative side by the UN Office of Outer Space Affairs. They're based in Vienna. And between the COPUOS sessions, UN-USA also does a lot of work on space applications and getting, countries that may not have traditionally had a stake in space to participate in the space industry, whether that's launching their own satellites or working on downstream space applications and trying to figure out how you can incorporate those in governance and in space sustainability. So that's sort of the main space UN body. And then there's another UN affiliated body, the International Telecommunications Union. And you have to file a license through the International Telecommunications Union if you're going to launch any sort of object into space that communicates with the ground, which is pretty much every sort of satellite that goes up there, because even if you're not a communications satellite, you need some way to downlink your data and communicate with Earth. And you file through your home country, but then they submit your application to the International Telecommunications Union if you want to launch something. And for both of these organizations, again, sort of the main theme is that you have to go through your home country, which then works with COPUOS or the ITU. So these governance structures were sort of set up so that the nation state is the one that figures out how to administer all these treaties and guidelines in their home countries. So where are we now in terms of satellites, which is what I primarily work on? We have over 2,600 satellites in space as of the end of 2019. But this is an industry that's really rapidly expanding to the extent that we are going, well, there have been over 120 satellites, 120,000, satellites proposed by 2029. So huge explosion in the number of satellites over the next decade. And that's really kickstarted a bunch of different conversations about who should have access to space and what sort of access to space is valid for a few different reasons. So one, space is definitely becoming much more congested. Last night, there was a near collision between two large pieces of space debris at this point. And we're worried that there is going to be some sort of cascading collision that could make certain parts of space unusable. And a lot of these areas that are very crowded are in lower orbits. So even if you want to launch something to a higher orbit, you'd still have to go through these congested areas to be able to launch your satellite, or it's also an issue with the International Space Station with astronauts having to launch there and then obviously live there. They don't want to be in any sort of debris field. So that's a really big issue that a bunch of people are working on right now, both at the international level, at the federal level, and then even across industry, and trying to come up with how to make sure everyone still has access to space. And again, we have to talk about this not only on a national scale, but on an international scale as well, because if you only implement this at a national level, a company could just go to another country and apply through them to get a license. So right now, this has been a big push for the National Space Council that Chris can probably answer questions about, and also for different regulatory agencies in the US. For the communications license, companies in the US have to go through the FCC, which then submits the application to the ITU. So the FCC has been working on a rulemaking for orbital debris mitigation. So anytime a company wants to apply for a license to launch satellites, they're gonna have to follow whatever these new guidelines are that the FCC comes up with. There's also an Office of Space Commerce in the Department of Commerce that is working on the space traffic management portion of this. And trying to, combine a lot of data and get data, make data that used to be, run by the DoD more commercially, more friendly to commercial academic users, and just combine data sources and hopefully use that to make good decisions in terms of space traffic management. But some of the areas that they're working on right now, and one particular is, should satellites have to be able to maneuver on orbit? Because if you can't move out of the way of something that's about to hit you, that could create a large field of debris depending on how big your satellite is. And that's, some of the bigger satellites, like these constellations of thousands of satellites proposed by SpaceX, OneWeb, Amazon, those are supposed to have the ability to maneuver, but some smaller satellites, like some remote sensing satellites, a lot of remote sensing satellites and academic satellites too right now are CubeSats. So they're 10 by 10 by 10 centimeter cubes. Sometimes you stack them, three of those stacked on top of each other is a fairly common form. But right now there's not really a good propulsion mechanism to be able to get them to maneuver quickly. So that's actually a big area of concern is, is there a certain altitude that we can allow these satellites to launch, whether they're for academic users? And from academic, I mean, even elementary schools have launched these satellites. Space is becoming far more accessible from a cost perspective, costing tens of thousands of dollars to launch a satellite versus the millions of dollars it takes to launch a much larger satellite. So there are a lot of people saying oh, maybe we should just launch the ones that can't move below the International Space Station, so they deorbit really quickly, and then don't run the risk of running into astronauts. But then there are other perspectives like remote sensing satellites. There are a lot of cube satellites that are providing these new innovative remote sensing satellite technologies. Like the company Planet can image the entire Earth at 1 meter resolution daily. And they've done a lot of projects on deforestation and water usage, things like that. And they are kind of in the 450 to 550 kilometer range, depending on their satellites. But they use different they use differential drag to, maneuver their satellite at a sort of slow speed, and they can avoid collisions if they know about them far enough in advance. But they're trying to figure out, they don't have any sort of technology right now to be able to move faster. And so there's this entire remote sensing industry that is kind of at risk of running into a major regulatory hurdle where they can't launch anymore, even though they're relatively small and might not create as much debris even if they did happen to have a collision. So those are some of the main areas that we're working on right now. It's an issue on the international front too. A big problem that we've run into is that at the COPUOS level, a lot of countries are not happy when commercial operators come in and talk about these issues. They feel that COPUOS and UN-USA are only mechanisms where nation states should have a voice. But we're at the point now where over 50% of the satellites, active satellites on orbit, are commercial. And we really just need everyone to sort of talk together and collaborate on these big picture issues. And we want to make sure that academic users can still have access to space. So there's a lot of effort in trying to just disseminate best practices in space sustainability at all levels, even if there aren't any sort of binding guidelines, and hoping that everyone can get on the same page there. And I think I'll leave it at that, and hopefully we can discuss more of these topics in the questions.
Thanks, Therese. It's such a complicated matter talking about space governance and who has access to it. So thanks for that. Our next panelist is Chris Beauregard, who is a policy advisor for the National Space Council. There he supports the office's priorities and civil. Great, thank you, Chris, for giving us some insight into how the White House interacts and communicates on these issues with your commercial and international collaborators. Okay, so we are going to go ahead and move into the Q&A. We have one question from the audience, which is similar to a question that I was going to ask. So I think we'll point this at Therese first, and then other panel members feel free to chime in if you'd like. Starlink, which is SpaceX's mega constellation that has already launched over 700 of their planned 30,000 satellites into LEO, and also OneWeb and Amazon have plans to launch their own constellations, have already impacted academia and research and science. Trails from these satellites impact the quality of science images due to their reflectability. So what is done to accommodate competing interests between the satellite industry and scientists? And can we truly estimate the impact of such satellites on science in the future?
I think that's a really good question. And the question from the Q&A, I think, was about regulating the brightness of these satellites and their impact on astronomy. So from a regulatory perspective, there isn't a framework in place right now to regulate satellite brightness, and this is why this has been an issue. The FCC is supposed to regulate environmental impact, but there's a blanket waiver for satellite space stations. And while that's something that the FCC could possibly consider in the future, the timeline of the FCC considering that, based on my experience in working with the FCC, and I should mention I used to be an astronomer, so I care about both sides of this. But the timeline of working with the FCC on incorporating issues like this takes on the order of years. And these constellations have already been licensed to launch. There's really not a way to revoke their license, which is a common thing I hear from astronomers. Let's just prevent them from launching until we figure this out. But from a regulatory perspective, that's not really how this works in the US. And there's not a mechanism on an international scale either to regulate this right now. Even if you could somehow protest this, I think there's a major case recently where not every branch of the government was very happy with an FCC decision to license a company called Legato. And that's gotten congressional attention because the FCC disagreed with DOD on their assessment of impact. But from what I've heard, the FCC seems like it's going to win on this one. They're an independent agency. They're not required to listen to any other federal government entity. So from a realistic perspective, I think there's been a lot of good work done in collaboration with, we work with the American Astronomical Society. We put on a workshop already, and there was just a UN Dark Skies workshop where, you know, a good number of our satellite operators did come. They discussed, you know, the mechanisms they're trying to take to reduce the brightness of these satellites. And Starlink in particular has really been trying hard to work with astronomers to mitigate this, because both SpaceX and astronomers were really surprised when Starlink started initially launching about how bright it was. And their goal is to get them below a visible magnitude. I know that still creates some problems in terms of astronomical observations. And there's some concerns with these other constellations, but I would say there's been a lot of goodwill put in on both sides, trying to talk about technical solutions to this to make space as usable as possible for both entities. And for those of you unfamiliar with these constellations, they do want to provide communication service across the world in areas that are currently unreached. So, you know, in the middle of the ocean, in the middle of the desert, and it's a service that can't, you know, be provided in any sort of financially viable way by any other mechanism. So I'm hoping that there will be more collaboration, but in terms of getting any sort of regulatory body involved soon, as I mentioned in my remarks, these satellites are, you know, set to launch by 2029. We may not end up with all 120,000. Very modest estimates would be 10% of those. Reasonable estimates are probably 30% of those. But another thing to keep in mind is that a lot of these satellites are designed to only be on orbit for 5 years. So we can iterate multiple times. Maybe there's more opportunity for feedback between generations of these satellites. So it's not like, even if they do have a negative impact on astronomy, they won't be up there forever. And hopefully there's time to work more on the solutions.
Great, thanks, Therese. We have one question. This is kind of common between two. I wonder if, George, if you could start with this, and then other panelists can chime in if they like. So what enforcement mechanisms are anticipated for state parties violating treaty and ethical issues, best practices, the like?
Yeah, this is a notorious gap in international space law. That is actually no way to enforce anything. The only way to actually enforce some sort of space law would be if it were a national space law. So if a space law goes from the international level to becoming a national states law, then typical law enforcement mechanisms used in national states would apply to that case. For example, in Greece, there is a law number, I think 4508/2017, if I remember correctly, which refers to space objects and the registry of space objects. It was, I think it came in force like 3 years ago when I started, like a year after I started my PhD thesis, and this was nice because I used Greece as a case study. So now that there is this, it is anticipated in Greek law that any company that would like to send some sort of an object in space, then yeah, they should follow this specific this law that includes aspects of international law and acknowledges the commitment of Greece to what has been stated and signed and ratified by Greece in the various space treaties. But as a national law, it is much easier to enforce it than it would be if it was just an international treaty.
Yeah, and I'll just chime in with what I was talking about before. The liability convention in the event of collisions does exist at the UN, and it's something that was passed, but there's no actual, you know, enforcement mechanism. It does say nation states are liable if there is a collision on orbit, but that there's only been one major collision that was sort of settled by, you know, the two countries involved, but it hasn't been like litigated in court. So it's really, remains to be seen what would happen if there was a major space collision. And that's a big issue in terms of space traffic management as well. Like if you have two satellites about to collide and the one doesn't want to move because it would expend too much of its fuel, and they effectively force the other person to move, there's no, liability or sort of built-in rule there.
Chris, I have one question for you. How will the Artemis Accords lead to greater cooperation and exploration?
Sure, I appreciate that question. So from our angle, the international partnerships that we have are going to play a key role in our sustainable presence on the moon and other exploration goals. And so now we're entering an era where we have more than ever commercial and private actors that are both looking.
We have another question from the audience, and I can open this up to any panelist. Since space has primarily been benevolent, or has been primarily benevolent investments until recently, how are the parties responding to congested, contested environments and the anticipated militarization of space?
So I guess I can take the first shot at that. So space, has always been used for military purposes, but it's been used for, remote sensing satellites that are gathering intelligence, it's been used for communications. And I think the line is definitely getting blurred between what is commercial and what is military for multiple reasons. There are government is, looking to, the US government in particular is looking to the commercial industry to provide a lot of space services for the military, whether that's remote sensing, whether that's satellite communications, rather than always building their own satellites. So there's a lot of talk about, if there is an attack on US space assets, will that include commercial entities that are providing services to the US government? And what sort of investment should be placed in the space architecture in the event that that happens? And what is a reasonable response to any sort of attack on space assets? It's seemingly less likely that there's going to be what's called a kinetic attack on space assets, where you might explode something because people are really recognizing what a problem debris is. But you can blind a satellite with lasers. You can also have a cybersecurity attack on satellite systems, and maybe the level of response is not as high for a cybersecurity attack than if there's a kinetic attack. Another big area that this is impacting, though, is this sort of new field of satellite servicing. Companies are starting to be able to, starting to invest in, and we had our first satellite servicing attempt last year, where these satellites are living for 15 plus years, but we're trying to figure out ways to refuel them on orbit. And so the first refueling mission was recently done, but there's a consortium called Confers that is trying to sort of create rules of the road for satellite servicing, because there are a lot of things that could look like satellite servicing, but also could be an attack on satellites, or, there also, we've had Chinese satellites coming up and getting really close to and inspecting satellites, but there's not really a rule of how close you can get. And what's considered hostile and not. So those are sort of the big military space conversations right now, I would say, on the satellite front at least. I don't know if Chris has anything to add.
No, that was pretty well summarized. One thing that I will add is—
Great, thank you. We have another question from the audience. I think, George, if you could answer this first, and Chris, if you have something to add afterwards. How does the planetary protection community consider launching experiments, specifically biological experiments that may be gaining function in biological organisms that could return to Earth intentionally or accidentally?
Okay, so the current planetary protection policy that is being promulgated by COSPAR takes into consideration target mission combinations, as we say. So if you want to run a biological experiment in orbit, then it's fine. Then a planetary protection policy does not apply. It only applies to specific mission and celestial bodies combinations, and only specific cases of mission and celestial body combinations, let's say, like call for strict planetary protection measures. If you can even conduct biological experiments on the moon, if it's in places that is like planetary protection category 1, or if you provide a detailed inventory, if I remember correctly, because of the recent change that has happened. Now the moon has 2 planetary protection categories, 1 and 2. I think in both categories you can conduct biological experiments. So only specific destinations would call for strict planetary protection measures.
Yeah, I don't have a whole lot to add to that. I think that was.
So I just wanted to say thank you to all of our panelists. I think this was a great conversation, really inspiring, and thank you to our audience for submitting such wonderful questions. We'll go ahead and wrap up.
Thanks a lot.
Thanks, everybody.
Great, thank you everybody for joining us today. I'd like to thank our panelists for participating, as well as Sara for doing a great job at moderating. And we'd just like to leave you with a call to action. If we've piqued your interest today in this topic, submit your space policy research to JSPG. Our next deadline is November 15th. You can also subscribe to our newsletter to keep up to date with upcoming events and issues, as well as follow us on Twitter, Facebook, and Instagram at Sciple Journal. And we also have a new podcast. As I mentioned, if you'd like to hear more from our authors, please subscribe to the YouTube and SoundCloud channels. And thank you again for joining us today, and have a great day.